That's workability. Kung gaano kahirap saka kung gaano kagaan haluin. So kung kukunti ang tubig, mahirap siyang haluin pero mas malakas siya. Pero kung mas maraming tubig, kukunti ang semento, mas madali siyang haluin pero yung strength naman niya is mas bababa. So may kinalaman yung water-cement ratio natin. So that's what we call a water-cement ratio. No? So those are affecting the strength and workability of concrete. So let's erase this. So moreover, reducing water in a concrete also has an effect on several properties of concrete. So reducing water will also, so ano sabi natin kanina, the strength increases. Ano pa? The permeability decreases. The water tightness shrinkage reduces. So yan. Yan ang mga effect ng water sa concrete. No? Now, on the other hand, reinforced concrete is a combination of concrete and steel. Wherein the steel reinforcement, yung steel reinforcement natin, it provides tensile strength. That is lacking in concrete. No? So steel reinforcing is also capable of resisting compression and is used in columns as well as in other situation. So sa reinforced concrete, si concrete ang maghahawak ng compressive strength si steel naman ang maghahawak sa tensile strength. So tensile force, no? From your theory of structure, meron tayong dalawang stresses. We have the compressive and the tensile strength. Let's say for a given beam, no? Meron tayong beam. Kung iloadan mo itong beam na to, may load dito, may bigat na hinahawakan. Anong mangyayari sa beam mo? So it will bend, no? Magbe-bend yung beam mo. Yan. So kung pansinin mo, yung mga fibers, kapag nag-bend yung beam mo, so this is an exaggerated lang, no? Hindi naman ganyan kapag nagbuhat yung beam mo, hindi naman ganyan ang bend niya talaga, no? So very, very, very minimal lang. So exaggerated portion na kunwari nag-bend yung beam mo ng ganyan, you will see that the fibers on the bottom is humaba siya. And yung fibers dun sa taas, ito yung mga fibers dito, humaba. And then yung mga fibers dito naman sa taas is lumiit, no? So ibig sabihin lang na compress yung mga fiber dito, so may compression dito. Dito naman sa baba, nagkalayo-layo siya, may tension doon. So this is in compression, this is in tension. And kung concrete lang yung beam mo, kung concrete lang yung biga mo, hindi kayang hawakan kasi ng concrete ang tension side. Ang mangyayari dyan, kapag walang tension na humahawak dito, nag-crack itong beam mo. So magkakaroon ka ng crack dyan. No? So ano ang gagawin mo dyan? So kapag para maiwasan ang crack dyan, naglalagay tayo dito ng bakal. So meron kang steel reinforcement dito. Yan. Yung bakal na yun ang hahawak dun sa tension. So ibig sabihin, yan na ang reinforced concrete. A combination of your concrete, which is the beam, and then yung bakal mo, which is the reinforcing steel. So question so far? May mga question ba? Ba naman? So let's continue. So therefore, this course enables you to know such information or vital information such as the advantages and disadvantages of a reinforced concrete as a structural material, and also a comparison of your reinforced concrete and structural steel for buildings and bridges, and the compatibility of the two material. So gaano ba ka-compatible yung dalawang materials na yan? So may I erase? Now first, let's take a look on the advantages of reinforced concrete as a structural material. So what are the advantages? So reinforced concrete may be the most important material available for construction. So it is used in one form or another for almost all structures, no? Great or small, like buildings, bridges, pavements, ano pa, dams, retaining walls, mga drainage facilities, irrigation facilities, and other. No? So reinforced concrete has a high compressive strength. Mataas ang compressive strength ng reinforced concrete. That is per unit cost compared with other material. And also, reinforced concrete has a great resistance to fire and water. Kaya yan yung ginagamit kapag firewall. Hindi ka naman magka-firewall ng bakal kasi madaling uminit ang bakal, steel structures, no? So the best material is reinforced concrete for that matter. No? And as compared with other material, it has longer service fee or life, no? Meron siyang longer service life compared with other material. Reinforced concrete can also be used indefinitely without the reduction of their load carrying abilities. And also the strength of concrete does not decreases. No? So yan, ano pa? Most economical. Kaya pansinin nyo sa Pilipinas, halos lahat ng mga bridge natin RC, reinforced concrete. May mga bakal tayo, may mga steel structures tayong bridge. But it will entail most costly, no? Saka yung mga cable stayed bridges. Mas mahal kasi yung mga kagamitan na ginagamit. Also, a special feature of concrete is its ability to be cast in any shape. Diba? Kayang-kaya mong i-cast in any shape. Kung gusto mo heart shape na kulong, pwede. Ano pa ba? Rectangle, pwede. Triangle, pwede. Kailangan mo lang ng form, di ba? Pero kung bakal sana yan, saan ka bibili ng heart shape na bakal, di ba? Saan ka bibili ng bakal na iba-iba yung kanya, yung what you call this shape. So ang hirap. So ano pa? A lower grade of skilled labor is required. So labor is also low, no? So kukunti lang ang mas kailangan mo, mas economical yung mga taong gagamitin mo kaysa sa ibang materials. Like for example, in steel, mag-hire ka pa ng steelman, ng what do you call this? Yung mga iba-ibang operator, di ba? So yun. Ano pa? The disadvantage naman. So okay na yung advantage. So high compressive strength, resistance to fire and water, long service life, economical, can be cast in any shape, and the labor cost is very low. No? So those are the advantages. Now, how about the disadvantages naman of reinforced concrete? Number one, it has a low tensile strength. So that requires the use of a reinforcing steel. Kaya meron tayong reinforcing steel para siyang tumulong sa tensile strength. So ano pa? Forms are required. So kailangan mo ng forma. Forms are required when casting. So para may cast mo siya into any shape. Next, habang tumataas, yung let's for example, a building. So nagiging massive yung weight. So habang tumataas yung building, let's say for example, if it is 5-story, and then comparing that with 10-story na RC building, mas mabigat na siya. So ang nangyayari kasi dyan, let's say this is the building, 5-story, and then dinagdagan mo ulit, bumibigat yung load dito, which is very critical kung tataasan mo pa. Kaya yung mga ibang high-rise building, ang ginagamit na nila is the structural steel. Kasi masyado ng delikado pag concrete yung gagamitin mo. So ano pa? What are those? Properties of concrete also vary. Depende sa pagtimpla, depende sa paano ginawa, depende siguro sa klase ng aggregate, sa klase ng simento, no? So property of concrete vary widely. Because also, pwede rin sa mga kung paano minix, di ba? Iba-iba ang pag-mix, iba-iba ang mga, what do you call this? So iba-iba ang pag-mix. So mixing, ano pa? The raw material. Siguro, yung ibang cement, hindi ganun ka-standard, no? Kaya nag-iiba-iba yung, what do you call this? The concrete, yung napoproduce na concrete. So those are the advantages and disadvantages of your concrete or reinforced concrete. And when it comes to compatibility of concrete and steel, they work together kasi. They work together beautifully in reinforced concrete structures such that the tensile stress is being carried by your reinforcing steel and your compressive stress is being carried by your concrete. So yung shortcoming ng isa, yung shortcoming ng concrete, natutustusan ng steel, parang gano'n. Next, for the design code, anong mga ginagamit natin na design code? Ito yung gagamitin natin, and also in your board exam, ito yung halos makikita ninyo na gagamitin. No? So the first is the National Structural Code of the Philippines, or NSCP for short. So this is in its 7th edition, year 2015. So in-update na siya sa 2015, no? And also, this NSCP, may mga referral code siya, no? May mga pinagkuhanan naman. Kumbaga hindi naman sariling atin yung National Structural Code, wherein yung mga structural engineers natin is may pinagbasehan silang iba't ibang code. Like for example, we have the Uniform Building Code or the UBC. That is the latest is 1997. Then binase ang NSCP. And then also we have International Building Code or the IBC. The latest is 2009. Also, we have the American Society of Civil Engineers, the code of ASCE. Latest is SEI 7-10. Also, we have the American Iron and Steel Institute, or AISI. That is Series 100, year 2007. We have also Reinforced Masonry Engineering Handbook of America. Also, we have the American National Standard Institute, or the ANSI. The latest is G-I 2007. Also, we have the American Society for Testing and Materials, or ASTM. So, dyan binase yung ginagamit nating code ngayon, which is the National Structural Code of the Philippines. No? So, okay na? Screenshot nyo na o picturean nyo na lang para ko. Go, so okay. Let's move on. Now let's go with the important properties of your concrete. What are the important properties? So, ang pinaka-importante dyan is we have the compressive strength. So, ang sinisimbolize niyan is F prime C. So, pag nakakita kayo ng F prime C na symbol, it means the compressive strength of the concrete. So, this is the capacity of structure or material to withstand pushing forces. So, the capacity to withstand pushing forces that are actually directed. So, this is actually directed. So, it is the maximum stress a material can sustain under crushing load. So, the compressive strength of concrete is determined by testing a failure of a 28-day-old 6 inches by 12 inches concrete cylinder. So, from your material testing, construction material testing, ang pag-test ng compressive strength ng concrete ay gagawa ka ng 6 inches by 12 inches na cylinder. So, the diameter is 6 inches. The height is 12 inches. So, this will be subjected to loading dun sa compression machine. Ilalagay mo siya sa compression machine, lalagyan mo siya ng compressive strength. So, iipitin siya dun sa compression machine hanggang sa mag-fail. When we say mag-fail, yung iba mabibitak, ano pa, or basta na lang hihinto yung compression machine. So, kunwari, ang binasa ng compression machine ay 17 MPa. So, that will be the compressive strength of the material. So, ganun ang pag-determine ng compressive strength, hindi actual. So, this is tested at 28th day. So, at 28th day, itetest mo yung concrete cylinder mo. So, may mga nagre-range. The usual compressive strength, the normal, I should say, at least 20.7 MPa sa actual. So, yan ang compressive strength. Merong gumagamit ng 25 MPa para sa mga bridge. Sa mga high-rise, it can go as up, no? As 32 or hanggang 35 MPa. So depende. So yan yung range niya. But the normal is 20.7. So yan. Meron din para sa mga masonry or slope protection lang, yung iba gumagamit ng 16.5 or 16.7 MPa or 17 MPa, no? So depende sa structure, saka depende rin sa designer, no? So sa pre-stress, it can go as 35, I think, or 38 pa yung iba. Or about, that is about 6,000 or 7,000 PSI. When we say MPa, that is newtons per mm squared. PSI naman, that is pound per square inch. Kaya PSI. So consistency of units ang mahalaga din minsan, no? So newton per mm square yung isa naman is pounds per square inch, PSI. So meron yung mga direct substitution lang, mag-ingat kayo doon, lalo na sa board exam. Meron yung mga direct substitution lang, but the units are interchangeably done, no? So that is the compressive strength of concrete. Moreover pala, when you are testing, let's say for example, itong cylinder na ito, tinest natin at 28 days. May graph din yung compression machine na ibibigay sa'yo. I-graph niya yung stress-strain relationship. This is the stress, this is the strain from your theory of structure. Unti-untiin niyang lalagyan ng load kasi ito, yung cylinder. Hindi naman bibiglain na ikakrack lang, no? So habang tumataas yung load, tumataas din yung stress, no? Linearly. Hanggang sa umabot sa isang limit. That's what we call elastic limit. Kung saan nagsisimula na siyang mag-fail, pero may kaya pa rin naman yung concrete mo. So tumataas pa rin siya, pero at this part, nag-change na siya ng strength. Hanggang sa dumating sa point na hindi niya na kaya, that will be his ultimate compressive strength. That is your FC prime, no? So pagdating sa point na to, wala na, nag-fail na siya, pa-fail na siya yung concrete mo. Hanggang sa bumitak, that is now the breaking point. So yan ang ibibigay sa yung graph ng compression machine. So yan. So okay na tayo dyan sa compressive strength. Any questions so far before we continue? Nakakasunod pa ba? May mga question pa ba? So I will admit first yung mga kapapasok lang. Do you have any question? May mga question or clarification before we continue? So if none, let's continue. So screenshot and I will erase now. So second is the static modulus of elasticity. Minsan tinatawag din siyang Young's modulus. Siguro Young's ang apelyido nung nakadiscover nito. And the symbol for this is letter E. So that is static modulus of elasticity. The simple formula for this is the stress over the strain of your concrete. So from the theory of structure, your stress is in sigma, your strain is in epsilon. So that's sigma over epsilon. In our NSCP, meron tayong mga pre-made formula na tinatawag nila na for normal concrete or normal weight of concrete, that is 2-3 kilogram per cubic meter. For normal weight concrete, your static modulus of elasticity is computed as 4,700 lambda square root of FC prime. And for uh, weight of concrete, other weight of concrete, other weight of concrete, that is more or less 25 kilogram per cubic meter. The static modulus of elasticity is computed as 1/4 pala. This is for 14225. The weight of concrete raised to 1.5, 0.043 lambda square root of FC prime. Ayan. Wherein the value of lambda according to NSCP, the value of lambda is equals to 1.0 for normal weight of concrete, and lambda is equals to 0.75 for other. Yan. So those are your formula for static modulus of elasticity, or tinatawag na minsan na Young's modulus. So the symbol for that is letter E. So any question or clarification with the static modulus of elasticity? Kung hindi given, yung, but usually, ginigiven naman yan, no? Ginigiven yan sa board exam. But there are instances, baka biglang sumro yung magpapa-exam, hindi niya i-given. You must know the basic, no? So the basic is stress over strain or sigma over epsilon. But if it is given that it is a normal concrete, you can use directly the formula EC equals 4,700 lambda square root of FC prime. Or for other weight of concrete between 1,400 to 25 kilogram per cubic meter, you can use the formula EC equals WC raised to 1.5 multiplied by 0.043 lambda square root of FC prime, wherein lambda is equal to 1.0 for normal and 0.75 for other weight of concrete. So other mahalaga na properties, meron din tayong dynamic modulus of elasticity, wherein it is the ratio of stress strain pa rin, stress over the strain, but under vibratory condition. Then we have also tensile strength, that is force over area, syempre. That is the maximum amount of the tensile stress that the material can be subjected before failure. No? So hihilain yung materials mo. What else? The modulus of rupture. Modulus of rupture. Or in an NSCP, that is symbolized as F sub R is equals to 0.62 lambda square root of FC prime. It can also be other formula, that is moment multiplied by the distance from the centroid up to the effective depth all over the inertia, or MC over I. That is the bending stress, kung maalala ninyo. Bending stress. So again, pakipicturean na lang, tapos we can delete. So those are other properties of concrete. So next, we have the properties of mga importanteng properties ng steel. So, meron tayong tinatawag na yield strength, of which the designer will read as the basis used for most of the rules given in the design code. So, meron tayong, say, for example, pag-yield 40, which means that is 40,000 PSI or equal to almost 276 MPa na yield strength ng concrete. Meron din tayong grade 60 which is 60,000 PSI. That is equivalent to our almost 414 MPa. So meron din tayong iba't ibang sizes. So, okay na yan. Also toughness of the steel. Ductility. It is a measure of the degree to which a material can strain or elongate between the onset yield and eventual fracture under tensile loading. Weldability, the ability to be welded. No? Apa? Durability also. Yeah. In commercial, ang mahalaga lang naman dito yung yield strength. So, dito tayo magfo-focus. In commercial, meron tayo ditong ESTM na ginagamit na code. Also, we have the PNS or the Philippine National Standard and the NSCP. So, sa ESTM, meron tayong grade 33, grade 40, saka grade 60. Sa PNS, sa NSCP is we have 230 dito, MPa, 230 MPa. Dito is 276. Pero sa NSCP, nagiging 280 ito. Sa design, ha? This is 280 when you're designing. Ito is 414. Ito is 420 yung ginagamit sa NSCP. Kapag bibili kayo niyan, meron yung nakikita nyo kapag ito sana yung bakal. Kung mapapansin nyo dun sa dulo, either dito or dito, may kulay, di ba? Nilalagyan nila ng kulay. Pagka white, usually, that is grade 33. Pagka yellow, that is grade 40. And pagka green, or minsan, ginagamit nila yung red, that is for grade 60. Pero yung red, ginagamit kasi nila para malaman kung weldable or hindi. So kapag red, weldable na grade 60. Pag hindi red, non-weldable yung steel. No? So yan yung ginagamit nilang code. So any question? Meron pa pala. I forgot the last. You have the modulus of elasticity of steel. So that is ES equals 200 gigapascal, or that is 200,000 megapascal. So those are the important properties of steel. So any question or clarification before we move? Mga tanong ba? Or any clarification that you want to add? Mga tanong ba or any clarification? Do you have any question? Colin Joy, Concepcion, may mga question ba?
Wala po.
Clear? Sige. So check ko lang baka meron pang nasa waiting room. Okay, so let's continue. Share screen. So, do you see the screen? Nakikita ba? Oops, sorry. Nakikita ba?
Yes, sir.
Oops, sorry. Nice. Okay, we go now with the structural elements of a building frame. Ayaw yung mga send. What happened? Okay, the structural elements of a building frame. So, sa isang typical na building, yung typical na building natin, wala. Nawala. So, this is a typical building frame. So, we have your footing, your column, a girder, a beam, a one-way slab, a two-way slab, and the surface load. No? Dito sa surface load, it is composed of your dead load and live load. No? Oops, mali. Okay, yeah. Your live load and your dead load. Okay, ayaw. Ayaw naman. So anyway, sige. So that is the composition of a typical building frame. So the surface load is composed of your dead load and live load. Wherein when we say dead load, ibig sabihin yung mga load na hindi mo pwedeng tanggalin sa isang building. No? Parang kumbaga fix. Hindi siya pwedeng maigalaw. Hindi siya pwedeng ma-move. For example, the weight itself of the building. Yung mismong weight. Yung mismong weight ng column, mismong weight ng pader na hindi mo kayang alisin sa isang building. Andun na siya. Hindi mo naman pwedeng ilipat yung column, hindi mo naman pwedeng ilipat yung beam. Ano pa ba yung mga hindi mo pwedeng ilipat? So yun yung mga dead load. When we say live load, those are the loads that can be moved. So pwede mo lang tanggalin. It can be moved, it can be deleted, it can be erased. So like for example, a chair, a table, ganun. So pwedeng yung table, pwede mo alisin sa isang building para wala na siyang bigat na hinahawakan. Or let's say a heavy cabinet, no? Pag may cabinet ka dun sa taas, may hinahawakan na load yung beam or yung column dun sa baba. Pagka inalis mo yung heavy cabinet na yun, so wala na siyang hinahawakan. Those are live load. Tao, ganun, mga people. So for example, we have conference, may mga tao sa hall, so siya pang load yun na hinahawakan ng building. Pero pag wala ng tao, pag umalis na sila, so wala nang load, wala nang live load. So those are the difference between dead load and live load. When we say one-way slab, yun yung slab na iisa lang yung direction of stress, no? So usually the length versus the width is very far or very malayo yung length versus width. Ganun ang one-way slab. Let's say for example, meron kang slab. Meron kang flooring na 10 meters long, pero ang wide niya, width niya is, let's say, 2 meters lang, parang ganun. So, 10 meters yung haba niya, 2 meters yung width. So, ano ang mangyayari pag niloadan mo siya? Ang mangyayari doon, parang ang nagbe-bend lang is yung, what do you call this, uh, if this is, let's say, something screen. If this is your slab, comparing the length with the width na mahaba, let's say this is 20 meters or 10 meters, and this is 2 meters. Pag nilagyan mo ng load yan, ang magbe-bend ay yung mahabang part. Parang beam ang magiging, uh, what do you call this, parang beam ang magiging interaction niya. No? Kapag hindi naman magbe-bend ng sa 2 meters yan. Let's say for example, dito, hindi naman siya magbe-bend dito sa part na ito, dyan sa 2 meters. Kasi ang bending niya is on 20 meters. That is one-way slab. Unlike two-way slab, that the length versus the width is halos parehas. Kung niloadan mo yan, let's say naglagay ka dito sa gitna, this is top view, no? Naglagay ka ng load dito sa gitna. Ang mangyayari dyan is magde-deflect siya dito sa along the length, and at the same time magde-deflect din siya dito. Parang ganyan magiging itsura ng deflection niya, no? So, ganun yung kaibahan ng one-way slab and the two-way slab. So, yun. And then, kung napapansin nyo, meron pang isang medyo nakakalito. We have the beam and the girder. But basically, ang mas malaki, basically, ang mas malaki is the girder. And at the same time, the girder holds the beam. But a girder can be a beam also. So, pwedeng yung girder is a beam also. But the beam cannot be a girder. So, yun ang kaibahan niya. Because parang mas matibay yung girder kasi yun yung hahawak ng mga intermediate beams. Then we have the columns and then the footing, wherein the stresses of the building will be transmitted to the soil beneath the footing. So, yun ang gamit ng footing. So, yung stresses, kung nakikita nyo, yung stresses ng surface load papasa ng beam, saka sa mga girder, and then yung stresses ng beam and girder, ipapasa naman niya sa column. Yung column naman ang magpapasa sa footing, yung footing naman ang magpapasa dun sa soil. So, this is a typical structural element of the building frame. So, definition of terms. When we say frame, what is a frame? What is a space frame? What is a moment resisting frame? What is a floor load? When we say frame, it is a formation of elements or members. So frame is a formation of elements and members. So for example, we have a formation of members vertically, horizontally. Katulad nung pinakita kanina, the vertical is the column and the horizontal are those beams and girders. So it is a frame. But it can be a two-dimensional and three-dimensional. Bakit hindi nagsusulat kasi dito? When we say two-dimensional, so two-dimensional, an example of two-dimensional is we have a truss. So meron tayong formation, sabi dyan, it is a formation of elements or members. Ang mga elements mo dito is we have the vertical, meron tayong horizontal members, meron din tayong diagonal members. So this is a formation of elements vertically, horizontally, and diagonally. Therefore, it is a frame. Yun nga lang ang kaibahan niya, it is a 2D frame. And kung dadagdagan natin ng depth, let's say meron ka pang truss dito or purlins na may truss din dito. So that will be a 3D. So it is a 3D frame. For yung example natin kanina, meron kang beam, meron kang girder, meron kang column. And also, yan. So meron kang 3D frame or that's what we call a space frame. May depth na siya. So yun ang kaibahan ng frame sa kanang space frame. So moment resisting frame, when we say moment resisting frame, it is specifically designed to resist earthquake. So it is a frame that is specifically designed to resist earthquake, wind, and gravity load. So that is a moment resisting frame. It is a frame that is specifically designed to resist earthquake, wind, and gravity loads. When we say floor loads, yun yung kanina, yung dead loads and the live loads. So it is a composed of your dead load and live loads. Non-permanent ang live loads. Ang dead load is permanent. Ano pa? Monolithic floor. Monolithic floor, kung sinabi natin na monolithic floor, yung pouring ng girder and slab are continuous or connected, simultaneously connected. The pouring of girder and slab is simultaneously connected. So they act as one. Kaya monolithic. On the other hand, when we say non-monolithic, yung kabaliktaran, beams or girders and slab are separately poured. So they do not act as one. So they are separately created. Ang una mo nang binuhusan yung slab or ang una mo nang binuhusan yung beam saka yung slab. Sa monolithic, continuous, dire-diretso ang pagbuhos ng slab saka beam. When we say slab, that is a flat horizontal panel that support the floor. No? So it can be supported by beam or girder directly beneath the column. So it is a flat horizontal panel that support the floor. So flat horizontal panel that support the floor is the slab. So sa slab, meron tayong dead load, meron din tayong live load. So again, dead loads, those are the weight of material that is permanently attached. Hindi mo pwedeng i-move, hindi mo pwedeng alisin. So it is permanently attached. Unless otherwise, kung inalis mo yung column, that's not a building already, that's not a frame already. So wala nga siyang dead load. At the same time, wala ding frame na nabuo. No? So it must be permanently attached to the frame itself. When we say live load, those are the loads that can be moved, no? Or pwedeng alisin. So these are non-permanent and in a short period of time. So meron tayong one-way slab wherein the short span to long span ratio is more than 0.5. So yun yung sinasabi ko kanina na yung short or the width na tinatawag versus the length, the long span is less than 0.5. So, ibig sabihin malayo yung agwat ng dalawa. The bending stiffness of one-way slab is computed as EI over L. Where E, again, what is E? That is the modulus of elasticity multiplied by the moment of inertia I divided by the length. So that is the bending stiffness. So its symbol is K. Positive moment is where the tension fiber is in bottom, while negative moment is the tension fiber is on top. No? So that is the positive moment and negative moment. So ano pa? Ano pa mahalaga sa slab? Shear stress, you have previously learned naman in elastic homogeneous beam that where stresses are proportional to strains, two kinds of stress occur, di ba? We have the bending and shear. And it can be with bending is equals to mc over I, where m is the maximum moment multiplied by the distance of the centroid to the effective depth all over the moment of inertia. And the shear or the horizontal shear is computed as the maximum shear stress multiplied by Q over IB. An element of beam is not located at an extreme fiber or at the neutral axis that is subject to both bending and shear. That's what we call principal stress naman. Kung sabay silang nagkakaroon ng stress on the moment and at the same time at the shear. Wherein it is computed as F sub P equals to F over 2 plus or minus the square root of quantity F over 2 squared plus V squared. So yan. Those are the principal stresses. Inclination of principal stresses, we have tan 2 alpha equals 2V over F. So yun naman kapag hinahanap is the inclination of principal stresses. So any questions so far? So for definition of terms, muna tayo familiarize tayo sa mga definitions. Kasi it will be used in problem solving. Like for example, namin yung shear nito. If you don't know the shear, meaning of shear, mawawala tayo. Longitudinal bars in one-way slab. So the steel bars should be fully covered for better bonding. So kung napansin nyo tayo form bar for friction and shrinkage and temperature bars for shear. For two-way slab, yung kanina sabi ko is nag-aarang ng dalawang connection naman na two-way slab. That is the short span, ang broadening span naman greater than 0.5. So these thickness on both sides are relatively connected or close. Kaya nag-mention sa dalawang direction. So the ways to strengthen two-way slab, yung mga iba gumagamit ng drop panel and at the same time na tinatawag din ng capital. Kasi kung masyadong malakas yung shear and punching shear, bubutasan niya yung slab mo. Yan. Pwede ring beam, kaya lang, it can entail additional space, di ba? Pag maraming beam yung nasa baba. Kaya ang ginagawa nila, drop panel na lang or capital. For the analysis of your beam, you will see that the cracks at the vertical cracks at the minimum angle of diagonal cracking is 45 degrees. No? So the main difference between a girder and a beam is the size of components. So in general, workers in construction industry refers to large beams as girder. So the main reinforcement in the beam, meron tayong closed hoop and the reinforcement at main and the stirrups for shear. So it is placed to resist shear stress, diagonal cracks, and splitting of concrete. Next, we have the column. Ang pinaka-delikado pag sa column is the bending versus the buckling stress, no? Or the buckling effect. Where buckling effect is due to moment and instability because of the applied compressive force. So yan, pag masyadong malakas yung stress dun sa beam na napapasa dun sa column, that will become a buckling effect. So it can be pedestal, short columns, or long columns. Mag-iingat lang kayo dito sa last part, dito sa long column, kasi it is very critical to, lalo na sa buckling effect. Yan. Column reinforcement requirement. We have longitudinal bars, yung mga nakikita nyo vertically, and the confinement, yung mga hoops. So this is the structural elements of a building frame. So any question with the basic? May mga tanong ba? May mga tanong ba sa basic? Okay, let's have a 10-minute break before we continue. Mga 2:30. So, sige. You can have your 10-minute break muna. We will start in 2 minutes. Okay, so let's continue. So next, we will discuss on the principles of a working stress design or yung WSD. So let's say for example, in your board exam, ang sinabi doon is solve the following problem using the working stress design. Ito yung gagamitin ninyo kasi dalawa yung method on solving reinforced concrete. We have the working stress design and the ultimate strength design or the USD. Step of bending and stages of loading. When we say uncrack stage, so from the word itself, when we say uncrack stage, hindi pa nagka-crack yung concrete mo, no? So we have an actual moment that is symbolized as M sub A and your cracking moment symbolized as M sub CR. When we say uncrack stage, the actual moment is less than the cracking moment. So every structure kasi meron tayong tinatawag na cracking stage or cracking moment wherein if it does not exceed, the actual moment does not exceed the cracking moment, the critical moment, hindi pa nagka-crack yung concrete mo. Kayang-kaya pa niyang labanan yung tension or tensile stress. The actual stress also is less than the modulus of rupture. So it's symbolized as F sub T that is less than F sub R or the modulus of rupture. So small loading does not produce tensile cracking. So at this stage, concrete resists both tension and compression. Kasi hindi pa nagka-crack. So ibig sabihin, may lakas pa yung concrete mo. So ang lumalaban sa load is meron tayong concrete stress for compression. It is denoted by F sub CC. Meron din tayong concrete stress for tension, yung lumalaban sa tension, which is symbolized as F sub CT, and the steel stress, wherein ang hinahawakan niya is the tension. That is symbolized as FS, SF sub S. So yan yung symbol ng mga gagamitin natin. So okay na? Can I delete it? So picturean nyo na lang. So again, in uncrack stage, buhay pa yung concrete mo. So lalaban pa siya ng compression and tension. And at the same time, your steel lumalaban sa tension. Kaya meron tayong tatlong lumalaban dun sa actual stresses. If this is your beam, then ito yung mga reinforcing steel. Let's say this is your base, this is your height. Your neutral axis, let's say dito ang neutral axis. And the distance from the extreme compression fiber up to the neutral axis, let's say this is X. And you have a positive moment wherein your transform section, since hindi pa nagka-crack, so buo pa yung concrete mo. And then your steel, it will be transformed into concrete. For the transformation formula, magiging N-1 quantity AS or A sub S or the area of steel. So yun ang pagkuha ng transform section from steel to concrete. And because it is a positive moment, your bottom fiber is in extreme tension. So extreme concrete tensile stress or fiber. Sa taas naman is we have the compressive fiber. Kasi we have a positive moment. Again, kung ito yung beam mo, i-review lang natin. If it is a positive moment, your deflection of the beam is pa ganon. Yan. So your bottom fiber is in tension, your top fiber is in compression. So now your top fiber again is in compression. So puro compression yan. So that is, the resultant of this is compression due to concrete. Sa baba naman, we have that in tension. So palayo. So that is tension due to concrete. And we have also tension due to steel. Nakuha. So we have three: compression due to concrete, tension due to concrete, and tension due to steel. This is the transformed section. Kailangan natin i-transform because magkaiba. We have a, what we call this, two material, concrete and steel. Kailangan natin i-transform yung steel mo into concrete area. How do we do that? By the transformation formula. N-1 over, N-1 multiplied by AS. Okay, so let's continue. Taking the moment about the top fiber. So magmo-moment tayo dito sa top fiber using the transformed section, that is base times height plus N-1 multiplied by AS. This quantity multiplied by the X. So ito transform natin siya para mailipat siya sa NA. So the distance, the moment arm, is the distance from the extreme fiber up to the NA, which is your X. That is equals to BH over H over 2 plus N-1 AS multiplied by D. And D is the distance from the extreme concrete compression fiber up to the steel. Ito yung D. They have the effective depth. So that is D. Then, your moment of inertia about the NA axis or the neutral axis is equals to BH cubed 12 plus BH quantity X minus H over 2 square plus yung steel naman ililipat din natin sa NA N-1 AS D minus X squared. So alam nyo pang maglipat? Maalala nyo pa ba from your theory of structure on how to move the composite moment of inertia up to the NA or the neutral axis of the transformed section na tayo. So i-convert kasi natin yung steel mo into concrete. Kaya natin ginagawa yung transformed section. No? So moving on. Your formula now for the concrete stress in compression. Concrete stress in compression, that is C sub C or F sub C sub C. F sub CC is equals to the actual moment multiplied by X over I and A. Your concrete stress in tension, that is F sub CT, that is equals to the actual moment multiplied by H minus X over I and A. And your steel stress in tension, that is F sub S is equals to N multiplied by the actual moment D minus X over I N A. Kung napapansin nyo, itong three formula na to is nanggaling sa bending stress formula, which is MC over I. No? So kung nakalimutan nyo yung tatlo, go back to the basic formula, which is MC over I. Yun nga lang, this is a transform section, so that your I must be in transform section. Ilipat mo yung I and A. Yun lang ang kaibahan niya dyan. All the other is the same. So again, your concrete stress in compression is in formula F sub CC equals mx over I and A. Your concrete stress in tension F sub CT equals m quantity H minus x over I and A. And your steel stress in tension, that is F sub S equals to nm multiplied by D minus x all over I and A. So screenshot, and I will delete the whiteboard. Okay. So for crack stage, from the word itself, the concrete now have a crack. It means that it cannot hold anymore the tensile stress. So therefore, in your crack stage, your actual moment is greater than the cracking moment. And also, your actual stress is greater than the modulus of rupture. At ang humahawak na lang, since the concrete is on its crack stage, ang hahawakan na lang ng concrete tama ba? So ang hahawakan na lang ng concrete is the compression, and steel is we have the tension. So nag-crack na kasi yung concrete mo. So ibig sabihin nun, hindi nakakayang hawakan ng concrete yung tension side. Steel na lang ang humahawak dun sa tension. So this is the crack stage. So again, if this is your beam, let's say this is B, this is H, this is your AS, then you have a positive moment. That means your top fiber is in compression, your bottom fiber is in tension if it is positive moment. So if this is your neutral axis. Since it is already cracked, your transformed section will now be, ang concrete mo na lang is sa taas. And your steel will be at the bottom fiber. So this is in compression. This is NAS. This is now in tension. So that will be your transformed section. Again, taking moment at the neutral axis. So summation M and A equals BX moment arm X over 2, that is equals to NAS moment arm D minus X, where your I and A equals 1/3 BX cube NAS times the moment arm squared. Your concrete stress, so that is F prime C, is MC over I. And your stress in steel, that is M, your C over I. So these are your formulas for crack stage. Your modular ratio, that is N, that is equals to your ES, or the modulus of elasticity of steel versus the modulus of elasticity of concrete, or that is equals to ES over 4,700 square root of FC prime. Ano pa? We have the modulus of rupture, FR equals the cracking moment times CT over IG, where FR also can be 0.62 of FC prime. So please screenshot. So any question or clarification? May question ba or clarification? Denzel Galapon? Wala na si Denzel?
Sir, may klase daw po siya.
Okay. Jenny Galasinaw. Any question?
Wala po, sir.
So ako magtatanong kung wala. Maalala niyo pa kung ano ang modulus of elasticity of steel from our previous kanina? What's again the modulus of elasticity of steel? Ano ulit ang modulus of elasticity of steel? Anyone? Because as you can see, in the modular ratio, magagamit natin yon. That is the formula modular ratio N equals the modulus of elasticity of steel over the modulus of elasticity of concrete. But what is the modulus of elasticity of steel?
210 GPA, sir.
200 GPA or 200,000 MPa. So don't forget that. And then your modulus of elasticity of concrete is 4,700 square root of FC prime. So let's take a sample. So okay na? Can I delete? Pwede na ba? So that will take an example. So let's take an example. So let's take this an example. So determine the properties of the transformed section and calculate the elastic stresses of the given beam with a base of 300 mm, a height of 500 mm, an effective depth of 2425 mm, reinforced with 332 mm diameter rebar. Use FC prime equals 21 MPa, and the actual moment is 30 kilonewton meter. So our solution steps, here are our steps. First, compute for cracking moment. Then second, determine if it is uncracked or cracked stage. Third, compute for X or the distance from the extreme fiber or extreme compressive fiber to the NA, and compute also for the transformed section of the moment of inertia about the neutral axis. Then D, resolve for stresses. So these are basically our step in this problem. So first, let's determine the cracking moment. So first, to compute the cracking moment, we need to isolate the base times height section 300 by 500. No? So FR equals 0.62 square root of FC prime. And at the same time, FR equals your cracking moment times CT over IG. So what is FR? 0.62 square root of 21 from the given. So can we compute what is FR? Or idiretso ko na lang. 0.6221 MCR 500 over 2 112 BD cube. This is 112 B D cube. Naalala nyo pa yung mga formula nyo ng moment of inertia? So what is MCR? Can we compute? 0.62 square root of 21 equals MCR multiplied by the depth over 2 over 112 multiplied by 300 times 500 cube. Anyone? Mark Vincent Serapion, what is MCR? Jairel Solidaga, what is MCR? Princess Joy Dulig. Flory Pacaro. Anyone? What is MCR?
Sir, laki naman na po.
Ilan? Yung consistency of units.
Ay, oh.
Ilan? Okay lang, kahit basta kwan. Sabihin nyo lang. And we will check. Sige lang. Ilan? Para i-compare natin. Anyone? Malaki talaga yan kasi F500 cube eh.
35.51, sir.
35.51. Anong unit?
MPA po.
It is moment. Hindi siya MPA.
KN.
This is KN meter. Dinivide mo siya ng 1 million, tama ba?
Opo, sir.